we focus on the production of integrated circuits. And the reason for this is that when you break down, say, a mobile device and even a data center server into its carbon footprint, actually the largest part of it is today from the manufacturing. And that's about 75% in the case of mobile devices. And around half of that is actually from the IC chips themselves. That's why it's important to look at the problem in the first place.
Welcome to the Ojo-Yoshida Report podcast. This is our chip manufacturing sustainability edition. I'm your host, George Leopold. Our guest for this deep dive edition is Lars Ragnarsson. He's a program director focusing on sustainability issues at Imec. That's the semiconductor R&D and innovation hub that's based in Leuven, Belgium. Welcome, Lars.
Thank you so much. It's a pleasure to be here.
I wanted first, before we get into your sustainability efforts, let's consider this. The past meteorological summer in the Northern Hemisphere was the warmest on record. There were new highs that were also the largest annual increases in global average temperatures compared to the same period in previous years, that according to the U.S. National Oceanic and Atmospheric Administration. So that's sort of the problem, our reality in a nutshell. So the centerpiece of Imec's net zero efforts is its sustainability, semiconductor technology, and systems initiative. So to start, Lars, can you take us through what I guess is a three-part SSTS approach, which involves virtual labs, adjusting process flows, and then developing a decision-making framework for sustainable manufacturing. Can you sort of elaborate on that program?
Sure. Thank you. I am sitting here and just reflecting on the heat we had this October weekend, and it is indeed still very warm here. So focusing on the semiconductor industry and particularly on the manufacturing part of it, that's what the program is about. We do not look today into, say, the usage of devices and the impact from the electricity used by these large data centers, but actually we focus on the production of integrated circuits. And the reason for this is that when you break down, say, a mobile device and even a data center server into its carbon footprint, actually the largest part of it is today from the manufacturing. And that's about 75% in the case of mobile devices. And around half of that is actually from the IC chips themselves. That's why it's important to look at the problem in the first place. Now, our program indeed is built on three pillars. The first one is about assessment. The second one is about improvement. And the third one is about disruption. And in the assessment, we look at current and future technologies and try to assess what is the environmental impact from the manufacturing. We build this bottom up, meaning we start really with the expertise we have in Imec, which is the deep understanding we have on the processing of advanced technologies, how you build a device from a silicon wafer to the final product. And we take these type of process flows, combine it with information about tools, about process steps, recipes, etc., to build what's called a life cycle inventory. From that life cycle inventory, we can then do a life cycle impact analysis to get information about, say, the carbon footprint of an integrated circuit. When we have that learning, we can then deep dive into it to understand where do we have the hotspots, what is the most critical parts of the process flow or the fab that needs to be improved, and define projects to try to go after those. And finally, so that's the improved part. And finally, in the disruptive pillar, we are enabling new tools and metrics for the engineers, say, to help them to go after more environmentally friendly solutions when they
Hmm.
develop new technologies.
Right.
Essentially, we are adding the E to the PPAC, so the power,
Right.
performance,
That is
area, and cost.
power, performance, area, and cost, right?
All right, yeah.
Yeah.
So adding the E to that, so we get to the PPAC E, is really what Disrupt is about, to try to take the environmental impact into account already in pathfinding and not as an afterthought
Yeah.
when the technology is already developed.
Right. So it sounds like you're trying to identify those steps in the process flow where you can squeeze the most sustainable manufacturing out of it and reduce greenhouse gases and get to net zero.
Actually, to do this, it is not really sufficient to look at the process step level. You need to look at the more from a more holistic view.
Okay.
I'll give you an example. If you look at patterning today, in a very advanced technology to achieve the density that is needed, say in logic or in memory devices,
Mm-hmm.
we typically rely on double patterning or quadruple patterning or repeats in general of lithography, printing, and etching. And that means that you will deposit and etch away layers multiple times, and you will use lithography many times. Now, if you can replace that, say, with a single print EUV with high resolution or another solution that can replace all of these repeats,
Mm-hmm.
even if you spend more energy in a single step, overall you will gain in energy because you avoid all of those other process steps. And if you only focused on the lithography itself, you would not see that. So you really need to look at a module level in that case to see that actually it helps to reinvent the full process module to get to a more sustainable solution.
Right. Right.
And that, of course, you can bring to higher levels. You can bring it all the way to the technology level, finding solutions for a more advanced node that can do the same thing as another version of it, which is less environmentally friendly, can
Mm-hmm.
be by really thinking outside of the box and finding new ways of doing it at the system level or at the manufacturing level.
Right, right. So it sounds like the best opportunities for applying what you're trying to do in SSTS are in what we call scope one, the sort of the internal operations of a wafer fab.
So uh, from the fab perspective, we look at scope 1, 2, and 3 in our evaluation.
Right.
Scope 1 would be the direct emissions from using process gases,
Mm-hmm.
fluorinating gases like
Mm-hmm.
CF4, NF3, and so forth.
Right.
Scope 2 would be the emissions that are related to using electricity.
Yeah.
And scope 3 are the emissions from anything else. And our focus is really on the upstream materials, the materials that are used by the fab, the chemicals and the gases, and
Yep.
how many emissions are related to actually manufacturing those materials.
Mm-hmm. Okay. All right. So IMEC has also identified I think you term a knowledge and a data gap. And the challenge there is, I guess, identifying, the process steps that may generate the most greenhouse gases. The example I can think of is a few years ago, a town in Oregon was pressing Google to release data on how much water they were using to cool their data centers, and Google was maintaining that's a trade secret. We can't discuss that. Eventually, they did release the information, and the town in Oregon was pretty surprised at how much water Google was using in their cloud data centers. How do you get around that mindset, and how do you get people to share that information that some consider a trade secret?
That is part of the reason why actually this program exists.
Yeah,
I mentioned that the carbon footprint of the IC chips in mobile devices is around half of the production, so around actually 40% of the total.
yeah,
Um, this is based on models. And those models in today's life cycle inventory databases is not available for the most advanced technologies.
right.
In fact, the most recent updates in this databases is for the 14 nanometer technology node.
Hmm.
And today, 3 nanometer is available.
Right.
Furthermore, for memory devices, there is no information really about 3D NAND flash, for example. That means that when you try to make an estimate of the amount of carbon or the environmental impact in general from your chip, as a fabless or system company that design a product, they
Right.
have to guess a lot. And
Yeah.
that's where we fill the data gap by actually providing information that is not available to the general companies, and which the unfortunately today the the foundries are not releasing to everyone. So it's difficult to get to that type of information.
Right.
And Imec and the SSCS program is providing a generic type of information, generic technology nodes. We are not tied into any specific foundry. What we are doing is comparing different technology nodes as they evolve towards the future for generic processes, let's say.
Oh, okay. Okay. So it sounds like you're sort of acting as a clearinghouse, and we've spoken with the folks that SEMI, the industry group, and they're trying to do the same thing so that they can sort of promote um, uh, uh, collaboration and transparency, because no one company is going to be able to do this on their own. It's going to take the whole ecosystem to make progress towards net zero, right?
Yeah, that's really crucial. We are part of the Semiconductor Climate Consortia.
Yeah.
We have helped to set up the projections towards the future as technologies are getting more complicated and how it
Hmm.
evolves, and therefore enable projections and different scenarios to how we can progress towards the future. And indeed, we need to collaborate across the value chain. It's not possible for a single company to become carbon neutral without the help of the others. The
Right.
fab needs all the equipment and material suppliers to do the same as well. Of course, a fabless company cannot become carbon neutral or
Hmm.
reach net zero unless their supply chain
Right.
does the same.
Right. Well, that kind of brings up the elephant in the room. Let me read something that was in yesterday's Washington Post about uh, Taiwan Semiconductor Manufacturing Company. It says TSMC consumed over 22,000 gigawatts of electricity last year, which is roughly equal to like half the households in Taiwan. And only 10% of the energy they used came from renewable sources. So obviously, for this to work, you're going to have to get TSMC involved in a big way, right? Because they're the guys who make most of the chips.
Yes, absolutely. I do not want to comment on any particular company's efforts. However, I am aware of many of them moving towards more renewable energy. I know that specifically TSMC just announced that they are moving up their target for becoming completely reliant on clean energy.
Yes.
And it is a big part of it because we are indeed using a lot of electricity. A lot of the
Hmm.
operations, a lot of the equipment and tools that are used in manufacturing use a lot of
Right.
electricity. So if you rely on, say, coal based energy, you will have a very large carbon footprint.
Right.
And clearly moving to a cleaner electricity will bring that carbon footprint down significantly.
Yeah, and I guess part of the problem for a company like TSMC is they don't have the access to renewable energy that you have in Europe and in the US. So that looks like to us like it remains a hurdle. So you've described the current centralized cloud-based ICT architecture as a beast, and and it's sort of like more or less it's a scaling of the client server architecture. Is a more sustainable architecture possible that would address the device and the demand side, the data centers that are energy hogs?
I'm not aware of ever saying anything along the lines of calling it the beast. Um,
But would you agree with that characterization?
so with the growth of artificial intelligence that we see, really the explosion that we have
Yeah,
viewed or seen in the last year, or even shorter than that, naturally there is a big growth of data demand, and as a result of that, I assume a lot of electricity that is needed to run all of these data centers.
right,
They run on high demand, high performance compute, um, and these will use a lot of electricity. So clearly, moving such data centers to cleaner energy is crucial,
right.
but also, as pointed out, the carbon footprint embedded in the integrated circuits in those data centers is also crucial, because it is, in the end, what will remain if you run a data center or clean energy,
Mm-hmm.
one of the most important parts. So to become sustainable, it is really crucial for those companies to invest in low carbon, say, integrated circuits
Right.
to support activities like the SEMI-SSC and the Imec SSTS program
Mhm.
to help find more sustainable solutions for the manufacturing part.
Yeah, right. And in other conversations we've had during this series, applied materials, Intel, they emphasize that they are trying to move to renewables. They're trying to reclaim as much water and recycle as many chemicals as they can, and they're looking for new materials that may make their operations more sustainable. So IMEC just put out a white paper on sustainable chip manufacturing, and it stresses that the entire supply chain needs to commit. So where does that effort stand, and how do you convince chip makers and their suppliers that sustainable manufacturing is a benefit and not just a cost?
Yeah, that is indeed a very difficult question to answer, because what really drives the industry still today is the cost. It is
Yeah.
about making money,
Yep.
unfortunately.
Yep.
And we are very good at that. The industry is very good at making money.
Right. We're
However,
talking about a probably $1 trillion industry by 2030. Yeah.
yes, indeed. However, there is a mind shift that we do see at a higher level. Say the fabless companies have very clear and very aggressive targets,
Hmm.
and so and this is percolating down into the supply chain. So that means that it has become already now a necessity to focus on the sustainability of the manufacturing. And some companies are a little bit behind on it and trying to catch up. Others are
Hmm.
well ahead and has been doing this for a long time. And for those companies, I hear good stories from some of our partners where they have internally enabled metrics that helps them to motivate the development towards more sustainable practices.
Right.
introducing, say, measures of how much carbon a certain part of their process or a part of their tool
Mm-hmm.
is worth, and therefore putting kind of an internal cost to it so that they can not only look at the price in terms of euros or dollars or yen to make a certain part or a certain process step, but actually also how much carbon and how much money it would cost to actually emit that carbon. And
Right.
having these two things together can help to actually drive the effort towards more sustainable products and more sustainable processes. So that's in essence what we are talking about from the manufacturing, the E and the PPACE,
Right.
also from product level to equipments and materials to have that part of the effect.
Mm-hmm. Mm-hmm. Yeah, and so it seems that some of these companies, big guys, Intel and so forth, who are building huge new fabs, are trying to bake sustainability into their operations because they perceive now that there's a return on that investment.
Yes, indeed.
Yeah. So it sounds like you're optimistic that some of these aspirational goals that IMEC and SEMI and their members have put forth are actually going to turn into action.
I already do see that. We do have a big challenge ahead of us because um, we are a very fast growing industry.
Yes.
And as we grow in terms of volume, at the same time, we are making more and more complex technologies. And because of that, we are fighting against increasing energy needs, increasing emissions, increasing material use from two sources. So the increase in the complexity of technologies and the increase in volume. And because these two multiplies, we have an exponential problem. That means that the gap that we are needing to bridge to get, say, following the Paris Accord agreement
Right.
is increasing. And that makes it very difficult for this industry and compared to many others, which are more, say, stable compared to the ICT, to actually come up with solutions that have a significant impact.
Mm-hmm.
So I'm carefully optimistic. When we talk to partners, everyone is on board. We do see momentum. There is a lot of good discussions, and things are starting really to happen. And as you can see, when you look at some of the big foundries, they are really making serious efforts now to make a change.
Right.
But doesn't mean that we are home yet. There is a lot of work to be done and a lot of changes that are needed in the processes and in the fabs to
Mm-hmm.
actually to reach the goals of becoming net zero for the full industry.
Yeah. Well, it looks like IMEC is laser focused on where the rubber meets the road, where we're likely to get the most sustainability in terms of how chip manufacturing operates as you go to smaller nodes and you got to use more electricity and so forth. So it does sound like you're focusing on the areas where you're going to get the most bang for the buck, so that will hopefully move the needle going forward. So Lars Ragnarsson of IMEC, we appreciate your time and best of luck in your efforts.
Thank you so much.
Okay.
And thanks for this nice conversation.
The Ojo-Yoshida report wishes to thank our sponsor. Members of SEMI are leading the industry group's Semiconductor Climate Consortium in its quest to accelerate the efforts to achieve net zero carbon emissions for the global semiconductor industry, using baselining and road mapping techniques or reporting guidance and sharing best practices. Learn more and get involved at semi.org.